Number 35 is asking about a Pareto chart. And this is covered in section 2.2. You can read about them. The main difference is that the bars are positioned in order of decreasing height, with the tallest bar first on the left side. 36 is asking about a stem and leaf plot. And what a stem and leaf plot does is actually list out all of the data, but does it in a way that's organized and helps you to try to see patterns in the data. So what it does is it cuts off the ones digit. So something like 28 would just be the 8 showing up on the right-hand side of the bar, and it's next to the 2 representing the 20s. And so 28's in our data, 34 is a value in our data. And then in the 40s, we have 41, 2 43s in our data, a 45, 2 47s, and a 49. And so on and so forth. We have a lot of numbers in our 50s, and that's kind of the value of a stem and leaf plot, is that you can see that there's more in the 50s. There's definitely more data clustered in the middle and less at the ends. Our largest value is 83. Our smallest value is 28. 37 is asking about a pie chart here and just to draw some conclusions, and so you'll have slightly different questions. In this one, the ones that are true is that 2 cautious drivers irk other drivers the least. It's because 2 cautious is only a 2% slice of the pie, which is the smallest percentage up there, so that's the least. Tailgaters irk drivers the most, because in this pie chart, 23% of the pie is relating to tailgating. Most drivers being irked by the same thing. For most, it would have to be over 50%. There's no pie slice on here that is over 50%, so that's not true. And in a pie chart, the percentages should always sum to 100% exactly, and you can check these values. They do sum up to 100%. In number 38, we're actually going to be creating a stem and leaf plot display. And right at the beginning of section 2.2 is when it talks about doing this, so you can refer back to that and see some examples. What we want to do here is we're going to split the decimal off and put it on the right side of the bar, and then the whole values, the different whole values, go here on the left. And so, for example, 5.8 would be one of these 8s in the right next to the 5. And so you need to kind of sort your data, put all the things, all the data values in the 4s together, all the 5s together, 6s, 7s, and 8s, and then in ascending order put their decimals. So from the 40s we have a 4.2, or from the 4s we have a 4.2, and we have 2 4.9s. So we have a 299 as the leaves when 4 is the stem. When 5 is the stem, we have 1 5.1, 3 5.8s, and then a 5.9 somewhere. There it is. And so those are all the leaves when 5 is the stem. And so do that for all of the data. Make sure you don't leave any of the data values off. It can be helpful to cross them out or make some sort of note that you've finished with each one and put it in its right spot so you don't leave any out. And then we're going to try to describe what pattern we see by looking at the data organized like this. And it gives us some choices here. And we can see that most of these measurements here are between 5 inches and 8 inches, or sorry, centimeters, between 5 and 8 centimeters. And so that would be all of these in the middle. There's just 2 that are over 8 centimeters, and there's just 3 that are below 5 centimeters. All the rest fall in between 5 and 8 centimeters. In number 39, we're creating a dot plot. And basically, every single data value gets a dot on a number line here. So we have all our numbers listed. There we go. And so since there is a data value at 110, there is a dot at 110. There's 3 data values here at 120 because there's 3 dots at 120 because there's 3 data values in our set that are equal to 120. And so anytime you see a data value, you put a dot, and that makes you your dot plot. And then we want to describe the data. What patterns do we see? most of the values are between 120 and 150 is out of these choices. That's the best description. And you can see that 120 to 150 is this huge chunk right here where there's a lot of the data right there. And there's a few trail ends with people with high blood pressure. That's what we're measuring here. And there's one person that's below that chunk. But most of the data is between 120 and 150. And number 40, we're going to be creating a scatter plot. And the idea with the scatter plot is there's two variables here. One's going to be graphed on the x-axis, in this case hours, and on the y-axis is going to be, in this case, hourly wage. And so for each data value, you find out where it belongs on each of those axes, and then you put a dot where that data value is. So, for example, someone in our data worked 32 hours and made $17.16. And so you would go to 32 hours and put a dot up at 17 hours and 16 cents. One thing you can do to quickly get this scatter plot is to copy to the clipboard. I'm going to hit Control C there to copy, and then I'm going to open it up in Excel. Over here in Excel, Control V to paste it, and then if I select all of the data with my mouse, I can go up to Insert, and there's a whole bunch of different charts you can do, and one of them is a scatter chart. And so you pick that, and it will quickly draw that scatter plot for you. And then that'll help you match it up to the correct answer choice in your homework. And is there any pattern or something we see there? And not really. It looks like it's starting to go up. More hours worked leads to higher pay, but then it dips again, then it goes up again, then it dips. And so the best description of this data would be that there is no pattern for something like this. Now, if this over here was what your answer came out to, it looks like there is a pattern. More hours worked leads to higher pay. This one over here, more hours worked leads to lower pay, and so on. Number 41, we have data over here that is shown in a pie chart, and it wants us to make a Pareto chart. So remember, a Pareto chart, we got that bar graph where the bars are just arranged in order from tallest to smallest. So there's really just two options for what it could be out of these two. And then you just got to make sure that the heights of each bar reflect what they're supposed to here. Summer's 36. It should be 36 tall for the first one, and it should be summer. And this one here looks like the same shape kind of, but it says spring there instead of summer. So pay attention to the x-axis, that it has the correct month under the correct height for that month, and then that they're in descending order. And the difference between how these two display the data, pie charts are great at showing how percentages relate to the whole. You can see how much each piece of the pie contributes to the overall total. You can easily see that from a pie chart. And then Pareto charts are great at showing rankings and comparisons then between the different data. And so specifically rankings with Pareto charts because they're in order. You can see which season is the most favorite to the least favorite.